Hello, welcome to part 4 of AQA Physics Paper 1, Higher 2018. Let's get on with question 5. Figure 8 shows the gas boiler used to heat the house. Remember, we're talking about house physics insulation last time. So hot exhaust gas, hot water, cold water, fuel. So we're heating cold water coming in here, some pipes, and hot water comes out. Describe how different energy stores are changed by the boiler. First, we've got the fuel. So whether it's gas or even if it's wood or anything, we still have chemical energy. So, so I'll put my pen on, there's a new page. So chemical energy. Okay. Okay, chemical energy, okay, is, oh, sorry, chemical energy from the fuel. Okay, is transferred to thermal energy as it burns. So the chemical energy store of the fuel decreases. Okay. The thermal energy of the energy store of the water increases. It's been transferred. And for the third one, the thermal energy store of the air increases because it gets hot too. Okay. So to heat the house, the boiler transfers 15 megajoules of energy in 10 minutes. A megajoule is 15 million in 10 minutes. Calculate the power of the boiler. Use any equation. Write any equation that you use. Okay, so let's think about what power is. So power, okay, is energy transferred, energy over time. Okay, so let's think about that. So yeah, calculate the power, make sure. So we've got energy, because joules is always energy, 15 million. Let's write that out. 15, we could write 15 times 10 to the 6, or we could write out 15 with 6 noughts. 15 million joules. So joules, energy is always measured in joules. When we see joules, it's always energy. 10 minutes. Right, so so this is going to be in seconds. This is in joules, J, and this has to be in seconds. Okay, so 10 minutes. Yeah, these are, well, this question is, it's funny actually, because you want more space for writing. If one taker hasn't given us that much room. Right, 10 times 60 is 600 seconds. Okay, so that's going to go under the time, 600. And that's going to give us 25000 watts. Okay, so they've given us the unit there, but remember the unit of power is the watt, the unit of energy is the joule. Okay, so people get those two mixed up quite a lot, but the power has got a time component to it. I'm just going to open the next question. Electricity. Zoom out a little bit. Oh, got a graph. Let's get a pencil then. Right. So it says a student built a circuit using filament lamps, so bulbs, okay, normal light bulbs. Sketch a current potential difference graph for a filament lamp on figure 9. Okay, so what's going to happen is it's going to be a curve. It's not going to be a straight line. Okay, the lamp, filament lamp, is not ohmic. Okay, so it's going to be a curve. So yeah, just to help to understand. Oh, made a little bit of the. Always in your papers, always use pencil, because obviously you can just rub out like that. Okay, if you do that, like actually smudge the page, you've got a pencil, it's fine. Rub it out. Okay, so yeah, always draw a diagram with a pencil. Probably know that, but just making sure. Reiterate. Right, so what's going to happen with the filament lamp? It's going to curve like that. It's going to go back the other way as well, because you actually pass electricity back through it. It's not a diode, so you can actually switch around the connections. The electricity will still pass through it. Okay, so what's actually happening there is that it gets to a point where the current gets so high due to it heating up that the voltage can't increase anymore. So remember, a filament lamp is non-ohmic. It will not follow a completely straight line. It will be curved like that, filament lamp. Okay, let's open the next question. Okay, zoom out again. The figure 10 shows a circuit with two identical, so they're exactly the same, filament lamps. Okay, so we've got battery or cell, okay. I1, that's current, I2, and I3. Compare the currents I1, I2, and I3. Okay, so this is a parallel circuit. That's important, not series, parallel. Okay, so if they are identical, let's just work through this slowly. If these bulbs are identical, then I2 is going to be equal to, you can write a maths way like this, I3. Okay, they are going to be the same, and I1, this one, is going to equal the two added together. Okay, because it's, think about it going through the circuit, they're going to come back onto this one. Okay, they're going to come back. So other ways you say it was, we've only got 2 marks, but other things you could say. I1, let's do I's like this. I1, because it looks into a 1, is 2I2, or you could have said I1 is 2I3. But those two at the top I wrote first, they will give you the 2 marks. Okay, they are also valid answers. You have to write all of those, no 2 marks. Right, let's open the next page. So let's go zoom out a bit. Calculate the charge that flows through the cell in 1 minute. Okay, so each filament lamp has a power of 3 watts and a resistance of 12 watts. Let's underline those. Have a different colour. Orange. Okay, 6 marks calculations can be long. Write any equations that you use to give the unit. Okay, so calculate the charge. Power. So we've got power and we've got resistance. Right, so let's just write that down. So P, I'm going to go back to writing in black. Just underlining the different colours to make it stand out. P for power is 3 watts. Resistance R, 12 ohms. Okay. So P is equal to I squared R. Okay. So I'd always write down the equation that you're using that they've said there as well, but you can actually get marks just for writing an equation. Even if you don't do the next thing, you still get marks for writing it. Okay, there's lots of marks for not that much work here. Okay, so let's put the numbers in. So 3, substitute, 3 equals, we don't know the current, leave that, I squared times 12. Okay, now this is equals and an arrow means carries on from the next one. That's a maths thing, math symbol, it's good to know. Let's rearrange. I equals the square root. I'll do it bit by bit. Let's rub that out for a minute. I'll do it bit by bit for you. You don't need to do it one go. You can do it in one go if you know how to do it. It's not wrong. I'm just going to show people who might be aware how to do it bit by bit. Okay. Let me go back to my pen. Right, okay, let's do it bit by bit. So we want to get I on its own. So we divide both sides by 12. Make it a bit bigger. So 3 over 12 is equal to I squared. Okay, it's good thing they've given us some room here this time. So grateful for that. Right, so then we square root both sides. Square root of 3 over 12. I'm going to put that in a bracket. Okay, equals I squared. I'm going to write it neatly in the next line. Oh, not squared. Okay, because I'm square rooting. Let me just write it neatly in the next line. So usually we put what we want at the front. So I'm going to put I. I'm just writing it again, but I'm just putting it the other way around. Same equation. Square root of 3 over 12. Okay. So that's current at the moment is 0.5 amps. Okay, 0.5 amps. So that's current. Now we need to find charge. So charge, let's set the equation for charge. Q equals IT. Right, do we have, yes, a time? Okay, we've got a time as well. So Q is for charge. I is current. T is time in seconds. Okay, so Q equals I is 0.5, 1 minute, so 60, don't have to do any conversion. Okay, that equals 30. Put that in our heads, couldn't we? 30 coulombs. Okay, coulombs. So charge is in coulombs. Okay. So charge. Oh, set it separately. I'll just write in one go. 30 unit C. Okay, you could also write just coulombs as words too. Okay. So let's just go through that a little bit. So 1 minute. So we've got time. Okay. Time, power, resistance. Okay. So let's go back. What different color? Okay. So that's power. Okay. That's power again. Okay, current and resistance. Okay, charge 30 coulomb. So yeah, there's nothing really other way you could have done that. I think I squared. I mean, this is obviously the correct way, and this will get obviously 6 marks. I'm just trying to think of other ways that could have been done. Okay. If this is my straightforward way, there could be ways other people did it. A bit more convoluted than that, but this is the most straightforward way. So I'm going to leave that on the screen. So thank you for listening, and I'll see you for the last part, part 5. Thank you and goodbye.